Next week, you'll hear from Richard Lamb. He will reveal some, I hope he will reveal some secrets of ICANN. ICANN is an acronym for International Corporation for Assigning Names and Numbers. That's next week. Today I have the pleasure of introducing you to Dr. Miriam Petruck, Senior Research at the Berkeley, who will reveal the secrets of FrameNet. Let's welcome our speakers.
Thank you very much. I'm not sure that FrameNet has secrets, although I am sure that we have not succeeded in publicizing everything that there is to know about FrameNet. And in this talk, I hope to provide information about FrameNet. Where we're going. The way FrameNet has been used in natural language processing, and if we have time, then talk about some implications for natural language processing. So first, I'll talk about FrameNet. And I'm not sure how many of you already know about FrameNet and to what extent you're familiar with what FrameNet has done in the last 20 years. So why don't you stop me if I say anything that's completely not understandable. So FrameNet is a corpus-based computational lexicography research and resource development project. The founding director was Chuck Fillmore, and it's based on his foundational work in frame semantics. You could read all the details about the principles and practices that the project adopted in what we call the book, and that's available on the project website. While FrameNet began as a computational lexicography project, it has become one of the go-to resources for natural language processing. I don't know if anybody here actually works in natural language processing or computational linguistics, and if you do, whether or not you had the chance to go to the most recent Association for Computational Linguistics meeting this past summer in Vancouver, where one of the plenary talks focused on the contribution of FrameNet to natural language processing. So FrameNet is definitely on the rise, so to speak. Let me give you some definitions about FrameNet concepts and constructs. We have a frame, which is a script-like structured representation of knowledge about some event or situation that the claim is language users need for understanding word meaning. And that structure also facilitates inferencing across events and their participants. FrameNet characterizes word meaning, and we call those words, if you will, a lexical unit, which we define as a pairing of a lemma and a frame. That is, we look at one sense of one word at a time. Frame elements are frame-specific semantic roles, and frame elements are actually triples of information. That is, it's the semantic role, it's the grammatical function of that word in that particular sentence, and it's the phrase type. So that triple of information is what's captured in a frame element. And this is important also because for the most part, to date, natural language processing application development has relied almost exclusively on just the semantic role, that is, the frame element. But FrameNet provides this other information, and we certainly believe that making use of all of the information would improve natural language processing. We have frame-to-frame relations, which are relations that link related frames, as the name suggests, and also the totality of frame-to-frame relations link frames into this hierarchy of frames that FrameNet has developed. And some examples of frame-to-frame relations are inheritance, which we use just the way any hierarchy makes use of inheritance. Another one is precedes, which is about chronological ordering of subparts of an event. Then we have annotation. So the annotation is an important part of the work of FrameNet, and the annotation documents the linguistic instantiation of frame elements with respect to a given frame and a particular lexical unit. And I'll give you an example of that in a minute. And then, crucially, we have valence patterns. After the annotation takes place, which, as I said, is a critical part of the work of FrameNet, we have automatic processes that compile all the information and produce valence patterns. And a valence pattern is the syntactic and semantic combinatorial possibilities with respect to a given frame, with respect to a given lexical unit in a frame. Let me give you a simple example. We define the attaching frame as an agent attaches an item to a goal by manipulating a connector such that the item is fixed to the goal. Alternatively, an agent attaches two items to each other, where each serves as a goal for the other. So here's a frame where we combine the symmetric and the asymmetric possible relationship. Here's an example. Then, and this is taken from our database, although I reduced the length of the sentence just for space reasons. Then Sapt tied the rope round one of the trees near the water. So the word with respect to which we're providing the annotation is tied. The agent in this sentence is sapped, that's a name. The item is the rope, and the goal is round one of the trees near the water. So once the FrameNet lexicographer or the person doing the annotation executes this many times over for each lexical unit, as I said, we have automatic processes that combine them. Collate them and then produce a valence pattern. And it's the valence pattern that serves as useful information for natural language processing, because the valence pattern tells or can tell the system what the mapping between the form and the meaning is. Currently, FrameNet has 1,223 frames, 13,369 lexical units, 10,542 frame elements, and that seems like a lot, but keep in mind that we define frame elements, frames specifically. Obviously, we recognize that an agent in the attaching frame may also be the same concept as the agent in, say, the giving frame. But in the giving frame, maybe we'll call that the giver, right? Because we chose names for frame elements that would be hints to the annotator what exactly this semantic role is. We have 1,872 frame-to-frame relations and over 202,200 manually annotated sentences. 14% of those sentences are what we call full-text annotation. And I mentioned that explicitly because computational linguists seem to be most interested in the full-text annotation, even though that data are only a relatively small percentage of the FrameNet data. And in fact, full-text annotation is really just many layers of what we call lexicographic annotation. And so if anybody is thinking of using FrameNet data in work that they're doing or some NLP application that they want to develop, I would encourage you to make use of all the annotations, not just the full-text annotation. I'll spend a little bit of time on recent developments in FrameNet, including those you see listed here, but I will only go into the last two that I list, in particular work currently being done on multilingual FrameNet and work that I'm in the process of pursuing with some colleagues about constructions. The relevant thing here is that, well, there are two relevant things. One, that since FrameNet began back in 1997, there has been research in a number of groups around the world developing FrameNet resources for other languages, and now I think we're up to about 10, though obviously not all of them is at the same point in development as FrameNet, the original, as I like to call it. And the other relevant point is that from the start, Fillmore always talked about lexicon and grammar. And the theories that he developed to talk about lexicon on the one hand and grammar on the other hand were frame semantics and construction grammar. And I believe that constructions play a very important role in language understanding, and then obviously as a consequence in natural language processing, and I'll get to that shortly. So multilingual FrameNet is an ongoing project. It began about a year ago, and I want to call out my colleague Luca Gallardi, whose work I'm going to present. I'm not actually involved in multilingual FrameNet, but it's a key part of work that FrameNet is doing now. So he provided material for me to use in this lecture. Okay, the goal of multilingual FrameNet is to align lexical units across FrameNets from different languages, and obviously that means aligning frames, right? Among the possible uses of a multilingual FrameNet resource would be in foreign language teaching and various natural language processing applications, including machine translation, cross-linguistic information retrieval, and so on. One of the stated goals of that effort is to facilitate input and contributions to FrameNet. I'm not sure to what extent the project is going to achieve that goal, but it remains a goal of FrameNet more generally. One of the criticisms we often hear, legitimately, is about the limited coverage in FrameNet. So another go-to resource that computational linguists have been using for a very long time is WordNet, and WordNet has many more entries, if you will, than FrameNet has. At the same time, FrameNet has much deeper semantic information and much more information about the relationship between frames than what WordNet provides in its synsets. Okay, so the kinds of questions that multilingual FrameNet asks are these. To what extent are semantic frames universal? In which, if any, semantic domains do frames in other languages differ, and do they differ systematically? What is the basis of such differences if they exist? These are the kinds of questions that multilingual FrameNet asks, and these are of interest primarily to linguists. I mention that here in particular because this is a computer science colloquium. People who work on FrameNet, for the most part, from the start of the project, have been linguists, not computer scientists, though of course we have programmers doing the development of the software that we use for populating the database, for doing the annotation, and so on. But I'm reminding everyone that FrameNet began as a lexicography project that instantiates, if you will, the theory of frame semantics. That said, of course, FrameNet is thrilled that computational linguists are using the data, and we're interested in developing FrameNet further to make it more useful to computational linguists. So the project itself has a lot of challenges, and I've listed here what those challenges, some of what those challenges are. First of all, the FrameNet itself has many data structures in it, and then when you take into consideration that other languages that have been, FrameNets for other languages that have been developed in these years also may have a multiplicity of data structures. And then, of course, the different languages are at different stages of development. Not surprisingly, of course, because without FrameNet, the original, as I like to call the Berkeley-based project, nobody would have started FrameNet resources for other languages. And the way those other projects started also constitutes a challenge for the multilingual FrameNet project. In some cases, for example, Japanese and Spanish FrameNet, each adopted wholesale, if you will, the existing infrastructure of FrameNet, the original, right? Other languages use different techniques to develop their FrameNet. So there's been work on, say, Swedish and English, where the resource was developed using various kinds of computational techniques to leverage the annotation in FrameNet to use for another language, right? We asked the question, what constitutes alignment? So certainly with respect to those languages that adopted FrameNet infrastructure to jumpstart the work for that other language, can you really talk about alignment if you just took what existed and adapted it for the language you're working on? And then, of course, we would want to automate the alignment as much as possible, and a question remains whether that is possible. Further down the line, once the new resource is created, the question is how to maintain it and continue to make it useful for all those developers who want to use the resource. And finally, the question is, how will we get a handle on growing the new resource, right? So thanks to Luca, we have some strategies for proceeding with the work. The main one being treating FrameNet as a graph. And that will facilitate restructuring and address the issue of multiplicity of structures, both within a particular database and then across the different ones. And the second important strategy is to do a pairwise matching. So English and German, or English and Japanese, English and Chinese, whatever two languages we're talking about. And he coined the name, the Berkeley recommended method, and even suggested that we could trademark that name. This is really a way to keep track of what's in each resource that is or isn't in the original, because we don't want to reinvent the wheel, and we don't want to run into duplicates that we might lose track of. And then the question is, and this is something, these are things that Luca is working on right now, can this method be operationalized, and can it be scaled, right? So this is, as I said, this is all work in progress. And in addition, another important issue for multilingual FrameNet is not just to provide the alignment links, but also to include the information about valence descriptions, the valence patterns, right? Because that's the guts, if you will, of information for natural language processing, right? The syntactic and semantic, the combined syntactic and semantic information. So Luca is also investigating using some form of word vector representations to facilitate including the valence description in information. So that's it on multilingual FrameNet. The next thing I'm going to talk about is constructions. And I'm assuming that people may need some background about construction grammar. So I've provided some definitions for you. A construction is an arbitrary constellation of linguistic structure paired with meaning on any level of linguistic description. So it could be lexical, it could be morphosyntactic, it could be pragmatic, and so on. The critical issue here is the pairing of form and meaning. So much the way we talk about the valence description as including information about the semantic role and the phrase type, as well as grammatical function, we talk about constructions as having a form and a meaning, taking us beyond just the syntax of a sentence or just the form of a particular phrase. A construct is the linguistic instantiation of a construction, and I have some examples for you on the next slide. And a constructicon is a repository of constructions. So the lexicon is a repository of information about words in the language or word usage in the language, and the constructicon is a repository of information about constructions, that is, those units, those linguistic units that are the basis of the grammar of the language. So far, nobody has produced a constructicon or a complete list of all the constructions of any single language, right? But you can imagine that for any given language, you'll find many constructions, right? And here are just a few that come up in English, but this is very far from what a complete grammar would require. So subject-predicate construction, which is a very abstract characterization of form and meaning in a sentence. Head complement construction. Some specific constructions are the day name of day part name. So we have expressions like Wednesday morning, Thursday evening, Tuesday afternoon, and so on. And then I've listed a couple of other constructions, some famous because of early work of Fillmore and his colleagues. The work that I'm involved with now with some colleagues is on construction recognition for natural language processing. So FrameNet provides a lot of good, useful information about lexical material. The FrameNet Constructicon, which is just a toy, if you will, provides information about some interesting constructions in the English language. Obviously, for natural language processing to get a real boost, it needs information about all of the constructions in whatever language is under consideration. So we are working towards developing tools and algorithms to recognize and analyze constructions while also growing a constructionally annotated corpus. And the two areas, the two domains of language that we are working on are causality and comparison. The idea being that choose any text regardless of the domain. It could be finance, it could be science, it could be any genre, and you'll find a lot of expressions of causality and of comparison. Are you with me? okay? And as long as I'm here, I'll shamelessly advertise 2 efforts underway that you may be interested in contributing to. First is the International Construction Grammar Conference, which is going to take place in Paris next July. And I, in particular, am interested in seeing more computational work at this conference. And another is a recently proposed workshop, joint workshop, for one of the major computational linguistics meetings on linguistic annotation, multi-word expressions, and constructions, all of which we understand are actually intimately related. You could find more information about any of these online. Okay, so now I will get to some information about FrameNet and natural language processing. Could you remind me until what time do I have to speak?
Until about 10 minutes to 1.
10 to 1, and that includes questions?
That excludes questions.
Ah, okay, great. Excludes questions, good. So I have 15 minutes to go through a lot of slides. Maybe I won't get through all of them, but I would certainly be more than happy to follow up with any of you, either after the talk or via email if you're interested. So the first natural language processing application that okay. Magic. Is semantic role labeling. And semantic role labeling is foundational to any natural language processing application. The basic question that NLP wants to answer is who did what to whom, right? And if you have annotated data that tells you who did what to whom, you could build algorithms that will label who did what to whom in a text automatically, right? And then how you use that depends on what application is of interest to you, right? So the earliest one was this work by Dan Gilday and Dan Jarafsky, and that began what Dan Jarafsky likes to call a little cottage industry of semantic role labeling. So much so that at the most recent ACL meeting, many posters were about semantic role labeling of various kinds, and many of the presenters had no idea that it began with FrameNet and don't know what to do here. Magic or lack thereof. Okay. So that really began the work of semantic role labeling. The who did what to whom is precisely the kind of information that FrameNet, frame elements provide, right? Now, FrameNet also provides information about when, where, and why those, whatever happened, did happen. And yet, so far, NLP applications have not made use of that information in FrameNet, but again, I would encourage people to look into that. So there have been a number of systems, and the ones that are highlighted in red are the current best performing systems. And I highlighted them in red because of other work that I am interested in doing to incorporate semantic role labeling, that is, automate some of the work that FrameNet now does manually, also to address the coverage issue, right? The more we can do automatically, the less time it would take. This obviously involves doing some testing on FrameNet, on these systems, on existing FrameNet data, to see how good, the quality of the results we get. I mean, no annotation, including so-called gold standard annotation, is perfect, right? FrameNet is always reviewing and revising the data when somebody points out an error, or at least questions how we've categorized things, right? So nothing is perfect. The question is, can we improve coverage while saving resources by incorporating automatic semantic role labeling into this system? So that's another thing that I'm working on. Another NLP application for which FrameNet is useful, we believe, is event extraction. And in a workshop in 2006, Fillmore and a couple of other FrameNet colleagues asked the question, what can linguistics contribute to event extraction? And in that work, they provided a frame dependency graph showing the frames and frame elements that are relevant to the sentence. The United Nations says Somali gunmen who hijacked a UN-chartered vessel carrying food aid for tsunami victims have released the ship after holding it for more than 2 months. That's just one sentence, right? And as you might imagine, FrameNet alone is not going to do all the work that needs to be done to have a system understand, or let's just say process, that sentence. The frame and the frame element bindings provide some of the parameters for event simulations that capture the relationships among the participants in a dynamic scenario, as captured in that sentence. So the frames provide the basis for identifying the roles of the various events and a way to identify the participants of those events. Now, other work is needed to get really what's going on in that sentence, and some of that work is accomplished through what Narayanan and other colleagues called simulation semantics, where they provide a rich model of event structure that simulates the events and their interactions. I should add here that the workshop was more than 10 years ago, and since then, a fair amount of work has been done in event extraction in different domains, so biological events and medical events, using both expert language and ordinary language. Keep in mind that event extraction is just one kind of information extraction, and the work that I've listed here are examples of different techniques and different domains, different genres, even different languages, where people made use of frame semantic principles and FrameNet data for information extraction. Because remember, we're always thinking about who did what to whom, when, why, how, where, etc., and you could use that information in any domain and for any language. Another NLP application is question answering. Again, who did what to whom, when, where, why, how. And the early work provided a novel question answering architecture to analyze a question and analyze the candidate answers by identifying the predicate argument structures and the semantic frames. I'll go on to, whoops, that was back. Go on to other more recent, slightly more recent work where frame semantic and FrameNet information was used to either improve question answering or to reformulate a question in order to retrieve the appropriate passage for then determining or trying to determine the answer. The time is running away. Another obvious use of FrameNet data is for machine translation, where frames provide the interlingua for translating between the two languages under consideration. And this work requires making use of FrameNet valence descriptions, right? I have an example here, but I'm going to skip over the example since we don't have that much time. Let me just say that translating between one language and another is not straightforward, right? So given a translation from English to some other language, and I chose Hebrew, this was from a talk I gave years ago at Tel Aviv University. Given the word like Thai, you have many translations into the other language. And only when you look at the argument structure do you know what sense is the one you need for your translation. So that's the information that FrameNet provides. And I'll be happy to provide a PDF of this presentation so that you could look at this in more detail and contact me if you have questions or other areas of interest later on. Okay. A more recent work uses FrameNet information to provide suggestions of what the translation ought to be. A current hot topic in NLP is sentiment analysis. Businesses, companies, for-profit organizations want to know, for example, what people think about their product or service, and we have lots of material online that tells us what people think about a product or a service. Just by way of example, Yelp. All the problems with Yelp notwithstanding. So the work here suggests using semantic frames as an anchor for sentiment analysis, and proposes extending FrameNet for doing automatic sentiment analysis. The important point being that right now, for the most part, sentiment analysis is quite limited. It's either positive, negative, or neutral. But sentiment is much more subtle than just positive, negative, or neutral. And the analysis of words and expressions as provided in FrameNet gets at some of that subtlety. This work, the work that I mentioned on this slide, gives some information about frame-based systems for sentiment analysis. And you could read the details when I provide the PDF. Another hot area is dialogue systems. Not surprisingly, we all walk around with our phones, and we all want our phones to give us all the information we could possibly ever want. And recently, probably post-Siri, every company wants to do voice search, which essentially means you're having a conversation with your smartphone. So you want your smartphone to talk to you as if your smartphone was a person, because if your conversation with your smartphone is not very natural, you might not continue to use your smartphone to get the information. And then I don't think Samsung and Google and all those companies will go out of business, but then they would be less inclined to provide better systems if people aren't using what they are providing. Okay. Question? Okay. So again, the information I provided on these slides is reference to existing work that use FrameNet and frame semantic constructs in the development of these systems. So the question remains, in 2 minutes, I think, what are the implications for natural language processing? Well, the things that I've very quickly gone over tell us that FrameNet provides frame-based information, right? And we know that logic-based knowledge representation is problematic, okay? Embodied construction grammar, which is one instantiation of construction grammar that I mentioned earlier in the talk, provides a computationally tractable means to represent FrameNet information. So we need something more than logic-based representation, because it only gets us so far. We also know that we need to go beyond lexical resources, essentially FrameNet and WordNet and VerbNet and other resources of that type are essentially just resources about words. And words don't cover everything that a language has. We have support verbs. For example, take a break, take a drink, make a decision. That's a support verb. The take and the make are support verbs. Yet those expressions are about decision, about deciding and drinking. They're not about taking and making, right? And we need multi-word expressions, anything from a fixed phrase to something more flexible than a fixed phrase. And we need constructions. We also know that metaphor in language is ubiquitous. It's all over the place, right? I once did an analysis of a small corpus. A full 1/3 of the instances of one verb that I was looking at was metaphorical. So if you don't have a way to track and understand metaphor, you'll be missing out on a whole lot of language. Most approaches are limited in scale, that is, they don't work on very large corpora, and they rely on syntactic patterns, not metaphor concepts. In terms of multilinguality, we now have a lot of languages for which there are FrameNet type resources in development. I've listed the ones I know, and not every day, but every conference I go to, I learn about another one. So now that I've given you this overview, I hope I've at least sparked some interest in looking at FrameNet and using FrameNet in your work. Thank you very much.
I wish we had more time because this is an example of big data.
Yeah, of course.
Well, for us, it is a very dear example.
Yeah.
So, we have like a 1-minute question, 2-minute question.
Yes.
I just have a question about the structure of all of it. You mentioned hierarchy and frame-to-frame connection. Is that primarily to provide context for things that wouldn't be understandable when you take them out of a larger text?
Not exactly. Let me give you an example of something that comes to mind. So, one of the first frames that Fillmore talked about a lot in the early days of frame semantics was commercial transaction, right? A seller has some goods and a buyer has some money, and there's this exchange that goes on. You can say that commercial transaction is a specific instantiation of transfer, right? So we want to be able to connect the concept of commercial transaction and the concept of transfer. In that case, inheritance might be the relation. So we want to connect related concepts. Okay? That's more the idea. And let's say, and some developers have used higher level frames, if you will, to sort out semantic roles for lexical material that FrameNet doesn't include. So let's say, this is not true, but it serves as an example. Let's say FrameNet didn't have a particular lexical unit in the commercial transaction frame, but it's related to transfer, so going up a level, or how many, provides at least some information about the structure of the event. That's...
Okay, thank you.